In the previous lecture, we had discussed about various scheduling algorithms. In today's lecture, we will be discussing about I/O management and disk scheduling. First of all, let us see the topic about I/O. I/O means various input-output devices. Today we will be seeing about I/O devices and about I/O management. So let us first see what is I/O. I/O means various input-output devices which are connected to the computer in order to perform various applications. Now let us see what are the various categories in which input-output devices can be divided. There are three major types of I/O devices or input-output devices. The first category of I/O devices, user readable or human readable input-output devices. They are easily communicable to human beings or computer user. Some such examples of user readable or human readable I/O devices are printer, scanner, keyboard, mouse and so on. The second type of I/O device is machine readable I/O devices. They are easily communicable to other electronic devices. Some such examples are USB drive, disk drive and so on. And the third one is based on communication. They are easily available in order to communicate with remote devices. Some such examples are modems, cables and so on. Now let us discuss about differences among each I/O devices. Each I/O devices will be different and it will be based on the following categories. The first one is data rate, that is the rate in which the data is transferred among each devices will be different. The second one is application, that is the use of each device will be different and based on it, its influence on the software will be different. And the third one is complexity of the controller, that is the influence of the operating system will be different and it will be filtered based on the complexity of the I/O module which is controlling the device. The fourth one is unit of transfer, that is each device will be transferring the data in various units. It can be as large blocks or a stream of bytes or characters and so on. The next condition is data representation, that is the way in which the data is represented or encoded will be different from device to device. And finally error conditioning, that is the way in which an error has occurred, how it is represented and how it can be dealt with will be different from device to device. So this is how each I/O device will be different from each other. Now let us discuss about organization of I/O functions. I/O can be performed based on the following three types. The first one is program based I/O, that is whenever a particular I/O function has to be performed, the processor will issue a I/O command. It will be done based on the process to the I/O module and then it will be waiting, that is the process will be given to the busy wait state till that particular I/O operation is performed and then the process will resume its operation. This is the first kind of I/O operation. The second type is interrupt driven I/O. In this case there are two types, one is non-blocking and the second one is blocking. In both the types the processor will issue a I/O command to the I/O module on the base of the process. In the non-blocking type what happens is the processor will continue the instruction of the same process and parallelly the I/O module will be performing the operation. And in case of blocking what happens is the processor is stopped, it is busy waited till the I/O operation takes place and the operating system will performing some other process. The third type is DMA or direct memory access. In case of DMA, the DMA module will directly control the data exchange between the main memory and the I/O module. The third type is DMA or direct memory access. In this case, the DMA module will be directly controlling or dealing the exchange of data between the main memory and the I/O module. So these are the three types of I/O programming being taken place. Now let us discuss the various evolution stages of the I/O functions. In the earlier stages, the processor could access the I/O devices or peripheral devices directly. In the further stages, I/O module or controller were acted as an interface between the processor and the I/O devices. In further stages, I/O modules were added along with the interrupts and later the I/O modules were able to access the main memory directly using DMA or direct memory access. In further stages, the I/O modules were even more enhanced in order to become a separate processor. In such cases, specially set instructions were given for each I/O devices which were tailor-made. And finally, each I/O module were also given a separate local memory and as a result it became a system on its own with its own processor and local memory. Now let us discuss about buffering. Buffering is the process in which input transfer of data takes place a little in advance of the request given, and output transfer of data takes place a little time after the request is given. It can be performed on two types of devices. First is block oriented devices and the second is stream oriented devices. Now let us see each type of device in detail. First is block oriented devices. In case of block oriented devices, the data or information is stored in the form of block of fixed sizes. In such cases, the transfer of data takes place as one block at a time. In such case, the data can be represented as block numbers. Here, disk and USB keys are some of the examples of block oriented devices. The second type of device which we are going to discuss is stream oriented devices. In case of stream oriented devices, the input and output transfer of data takes place as stream of bytes. Here there is no concept of blocks. As a result, in case of stream oriented devices, the data will be inputted and outputted in the form of streams. Here some of the examples are communication port, terminals and so on. Most of the devices which are not secondary storage are examples of stream oriented devices. Now let us discuss about how data transfer takes place by operating system in case of different buffers. The first example we will be seeing is when no buffer is present. When no buffer is present, the operating system will directly transfer data to the IO devices. In such cases, it won't be waiting for any buffer. Secondly, let us discuss about single buffer. Single buffer is present in the main memory in between the operating system and the IO module. In such cases, whenever the operating system has to access the IO module, then it will be giving a buffer in the main memory, and then whenever the buffer is free, it will be able to access the main memory. The next type of buffer which we will be seeing is double buffer. In such cases, two buffers are used instead of one. So as a result, when the process is transferring data in and out of one buffer, the operating system can in turn empty and fill the other buffer. This is also called as buffer swapping. Finally, we will be seeing about circular buffer. In such cases, two or more buffers are present. Each individual buffer are part of the whole circular buffer. In such cases, we will be implementing circular buffer mainly when the IO module has to run in parallel with the process. Now let us discuss about utility of buffering. We all know that buffering is being used in order to smoothen the peaks of IO demand. But eventually, when there is a high demand of IO devices, in such cases all the buffer will become full, and as a result the advantages may reduce a little bit. But in other cases, when there is a variety of IO devices and process services are also present, in such cases buffering will increase the efficiency of the operating system, and moreover the process performance can also be increased using buffering. Till now we have seen about various IO management techniques being used. Now let us discuss about various disk scheduling algorithms. For that, first let us see about what are the various disk performance parameters present. The actual details of a IO disk operation will be based on the following three items. The first one is the computer system on which the particular operation is taking place. The second is the operating system which is performing that particular operation, and third is the nature of the IO channel as well as the disk controller hardware which are performing the operation. Now let us discuss how to position a read-write head on a disk. Whenever a particular disk is being operated, it will be rotating at a constant speed. In order to read or write a particular information on a disk, it is required to place the read-write head on the disk at a particular desirable track in the beginning of a desirable sector of that track. In such cases, the time involved for that particular head to be placed in the desirable track is called as the seek time, and the time involved for the disk to rotate from the beginning of the sector to reach the head is called as the rotational delay. The sum of the seek time and rotational delay is the required access time of that particular disk. Now let us discuss about various disk scheduling algorithms. The first disk scheduling algorithm that we are going to discuss is first in first out. In case of first in first out, all the processes are given equal priority. So as a result, according to the sequence, they are selected. As a result, it is fair for all the processes. The approximate performance is equal to random scheduling in cases when there are lot of processes waiting for the disk. Now let us discuss about the second type of scheduling algorithm, which is priority or PRI scheduling algorithm. In this case, more priority is given for jobs which are shorter batch jobs or which are more interactive as compared to the longer jobs. As a result, shorter batch jobs or interactive jobs will be performing better and the performance of the interactive response time will be better. Moreover, the longer jobs or database systems are given lower priority. As a result, the response time for longer jobs will be more. In this case, the priority is not given for data utilization, but other objectives are given more importance. Moreover, the control of the scheduling is present outside the disk management software. Now let us discuss about the next type of scheduling algorithm, which is shorter service time first algorithm or SSTF algorithm. In this case, IO request which needs minimum movement of arm of the disk is being chosen first. As a result, minimum seek time is being chosen for the process. Now let us discuss about the last algorithm, which is SCAN algorithm. It is also known as the elevator algorithm. In this case, the arm of the disk will be moving only in one direction at a time. So as a result, it will be servicing all the requests which are present in that particular track till the end of the track. Once the end of the track is reached, then the arm will come back in the reverse direction. Now let us come to the end of this session. In this session, we have discussed about various IO management and disk scheduling techniques. Hope all of you understood about it. In the coming session, we will be discussing about various file management techniques. Thank you.